So the next segment of my talk sort of is about the form function interface and how it interacts with C nicely. One of the niches Rust wants to get into is, say, if you're a Python dev or something, and you want to write like a C extension to Python, so it's quite fast, so it's like your core loop. Instead of reaching for C, you'll maybe go reach for Rust and just be able to use that instead, and not sort of at risk for causing your Python app to cycle things because you've written some mistakes in C code. So it has also another use of the form function interface is there are not like all libraries are not in Rust yet, but it's quite easy to grab a C library and wrap it so you can use it from Rust nicely. I did this with the Curelet-Balan library because I had some other project that used that, and I could try writing this from Rust again. But just sort of wrapping it nicely in Rust was not that hard at all. So it also has a nice tool called BindGen, which can generate Rust sort of interfaces from .h files. This was a huge time saver when I was not even time saver, made things possible when I wanted to work with this. So if I have some C code I want to call it, I will say there's some external function called double input, and it takes a C int and returns a C int, and that sort of handles type def. And then when I want to call it, I will call it, and the only restriction is that you have this unsafe keyword, where, which I should have talked a little bit about, which marks it as sort of not checked by the compiler. Because it's in C, you can't have the compiler go check things for you. Rust only sort of guarantees safety if you don't use any unsafe blocks, because if you could easily forge a null pointer and pass it back in and say, look, it's totally a reference to something, and then cause some Rust code somewhere else to break. So use unsafe sort of carefully, and hopefully if you get a safe one or anything, you'll have much smaller area to look, because you can look at the unsafe blocks and sort of audit them and be like, oh, it's probably here. A lot of Rust's standard library implementing things like vector uses unsafe blocks to sort of say, I have this block memory and here's how I'm sort of managing it, so that you can sort of implement things that the compiler wouldn't be able to sort of, isn't smart enough to check for you, then it is safe. So a lot of sort of primitives are, you don't have to write more primitives like they don't say, but you can use these to sort of use C pointers and go ahead and just sort of take control of areas so that you can write even things that the compiler couldn't sort of see that these are true. Because this compiler, for example, can't see that two references to different elements of the array with different numbers don't conflict, because it's not how numeric analysis engine inside the compiler to check that these numbers are actually different. But you can have a split act function which sort of splits the array into the first half, second half references to subsegments of the array. That works just fine. And you can use unsafe to put this, even though the compiler wouldn't be able to tell this is definitely safe. And then if you then audit your unsafe blocks, you'll be able to sort of use them behind the interface that you know they were there. And I'm off topic from this perspective. If you now want to call Rust from C code, you can specify the calling convention, like start C, you can, and then you can just link them. It'll generate sort of compatible C code, and you can sort of call it as long as you've got the equivalent sort of header declaration of the function. It's got a no manual compiler annotation on it saying, sort of don't namespace this based on sort of which module you're in, which we'll just use this as the exact name. There's also a few different kernel conventions you can use. There's like interrupt and other ones if you're sort of writing those parts of the operating system and you want to do like an interrupt vector for an event. There's also a kernel convention for that, which is different, but it has your back for that too. So the Rust standard library, which we're going to sort of be ditching, is broken into several crates, which is sort of independent compilation units, which can span several source files. There's the core, there's the alloc, which handles sort of memory allocation and hooks into either the system allocator or the JEmalloc. Collections depends on the allocator and the core, and has things like the completion of vectors and so on, and strings. libc contains sort of definitions that hook into this libc C setup library, and then all of these sort of are combined into one large crate called std, which you then can use from Rust code to use land to go ahead and do whatever you want to do, like open files, and doc network, whatever you want to do. Get back to this species.
alloc deals with ownership too? Alloc.
Alloc?
Yeah, deals with ownership?
Ownership is more built into the compiler. Alloc handles things like getting access to the heap. So alloc is sort of access to the heap, and malloc is very kind of thing, but it had sense for you. So you can say most of it just core, and this will sort of not have access to the heap. You won't have access to libc, no like system calls or anything will be installed, so you're not going to be able to say, let me open a file or something. But this is in fact quite useful because you don't need to depend on it being sort of in user land. You can sort of bare metal, go ahead and use Rust. So why would you throw out the nice useful things like allocating memory and being able to like talk to files and the network or like embedded devices or what they be using this for? Or kernel modules, for example. You don't want to rely on there being system calls you can call into when you are in fact a kernel. And in fact, running the entire kernel would probably want to be using this. So there's a kernel being written in Rust called Redox, which is probably quite good. So for the first foray into writing Rust without libc, without the setup library, I long ago learned C by trying to write some stuff for the Game Boy Advance, and actually from DS. It's imaging. This is an ARM7 processor. It's got some nice fancy memory mapped I/O to handle sprites and things. And I sort of went back to the tutorial and we'll see from it, sort of rewriting all the examples of Rust, which was a fun project. This did not, of course, depend on libc and it was allocate memory and everything, since the way you got memory there was like, well, you know that VRAM is from this address to this address, and go ahead and use it. So that's one area where I was using sort of Rust without anything else to fun, like Etch-a-Sketch programming things. I've written in Rust. So cross-compiling from ARM was pretty painless. It even got easier afterwards. It's LLVM backend, so I already had it. I had to write sort of a JSON file which had the LLVM information for like what the target was, and then I can just specify target was this, so telling me what the CPU was. I had a tool chain for compiling the C, so I linked that compiler. It also had the C runtime library, CRT0.s and all that. So that to initialize your global, your static variables and so on. Then for a project last winter, a year and a bit ago, for a course, I wrote a Linux kernel module. So I had a tiny device driver, which did the ROT 13 echo thing, where you write into it, and if you accidentally write it into ROT 13, you're going to looked into it before. And then I also rewrote a section of a USB mass storage driver in Rust, just to see if it was possible and make something similar. That's on my GitHub. This was an interesting project. I learned a lot. There was some casting rule. I wrote it both in C and in Rust, and I was getting some errors for the ROT 13 part, where signed characters and unsigned characters cause some unhappiness, actually, when I was writing. So the Rust version actually helped me debug the C version when I realized there was a casting error. Unsigned characters were better this time. Cons is a lot of existing C code in the kernel. I'm not saying that like writing a kernel module in Rust is like the best thing. Kernel is not very clear on all the things being like, are they signed or unsigned? And in C, it sort of implicitly can cast between these two. In Rust, it requires an explicit cast each time, and that got really tiring after a while. Like, return value as I32, check against negative 1 or whatever. If it's negative, it's an error. And then later it's used as a positive value, or an unsigned value into structures and things. Which, and also for Game Boy Advance code as well, it's kind of annoying where arraying the scenes are unsigned numbers, but I want to use signers meant for like where my pixels, where on the screen you are, so that I can like subtract and add and not like crossing the zero boundary and causing background. There was lots of unsafe code when I was writing the kernel module because I was sort of writing C code with Rust syntax, and everything was basically one giant unsafe block. And I wasn't really using features of Rust for safety. There was a few things it did, but and there's quite a few times in the kernel where it's saying casts a pointer as one struct type to a different struct type to access different fields and things, which was somewhat, it was not the way that Rust would do things at all. And I'm not entirely sure about if I was violating the aliasing rules by changing the type of pointer I have. And so I was going to perhaps tickle some undefined behavior in LBM because Rust has more strict aliasing rules than C. So just sort of line by line going from the C kernel module into a Rust kernel module was not, it was kind of pointless, but like, was possible to do, which was a big surprise to me. The first time I gave this talk, actually, I just finished concluding that it was impossible to do this because there was so many, I was trying to manually align the struct sizes and things because I didn't have, binding wasn't working properly on my Linux kernel drivers. But during the talk, actually, somebody in Germany opened a pull request which fixed bind gen and got it working for my project, so it could in fact just go against the Linux kernel module or Linux kernel header files and generate a compatible sort of struct definitions for everything, which was really nice. So I think I learned, so if you say something is impossible, somebody will come and fix it for you. Yeah. So actually, I guess it kind of happened again because last time I gave this talk, this was sort of 2 weeks ago, somebody wrote a very nice kernel module for FreeBSD kernel using Rust, which put, instead of just relying on core, they ported alloc crate to depend on KWLUG, and then ported collections and things on top of that. So they can go ahead and use vectors and things in their kernel module, and it made things a lot nicer to use, actually. So their kernel module was a lot, they were a similar scope, but it was a lot nicer and more idiomatic, and sort of written a little translation library on top of wrapping the kernel interface, so it can just be like, even some user IO writer, go write this data. I haven't explained all this in next time. But needless to say, don't worry about it, it's not important. But I was excited because they had written much more idiomatic Rust code than using the kernel module. So the sort of state of the art in kernel modules has improved since our last talk. And I was like, I don't know how nice it would be to actually use it. Now people have gone and written sort of much nicer interface around it, so you can write more idiomatic Rust code interacting with the FreeBSD kernel at least. I should really go and step it up and try and port the changes into the next kernel and see if I can get something nice in the free time. So, and the last thing I've been working on a bit was Arduinos, and they're not quite ready yet. So the ADR architecture is not that well supported in LLVM, and there's a branch of LLVM and a branch of the Rust compiler which do target it, and it does work mostly. There are still quite a few bugs, and it's nowhere near being stable. But if you're really excited to like run 8-bit ADR code that was compiled from Rust, you might be able to test it out. There's a few like assumptions that are being violated, but it's like the biggest size and just like UA. Like we run at 8-bit architecture, but it still sort of works. So it's one of the larger Arduinos, of course.
Well, if someone had an Arduino and wanted to play with Rust and their Arduino, what would they Google for to apply the project? Would it just like Rust and Arduino?
Yeah.
Get them to the right place?
Yeah. Yes. Yeah. Rust Arduino will get you to blog posts about it. So yeah, there's a few Arduinos which actually use not like the ADR architecture and 32-bit architecture instead, and those were fine. Like if they're using ARM or something, go for it. There's a few people actually playing around on the Discovery boards, which I should have put a reference to over here. As well as like Raspberry Pi type things. There's a project, zinc.rs, where people are sort of generating references to UARTs and clocks and things. And sort of like the config to go along with your code so you can port it to different boards very nicely. So there's some work being done on there. I don't know how cross-board compatible that yet, but there's a project in the works working on that as well. So yeah, conclusion, I'm running out of slides, so Rust is pretty fast and expressive. It's not actually matching anything code, but it's pretty fun to use. And that's end of my prepared slides. For like questions or everything. I have some other projects open on other tabs as well.
That's what I was thinking as a question of. Are you still using Rust? What are you using for?
I haven't been using like Rust professionally or anything. I actually got worked at doing Google's Summer of Haskell as a mentor instead. I was considering using Rust for 20% of the time. I'm a Googler, by the way. I advertise that. I'm currently going to be mentoring Haskell this summer instead. But I still have some for fun projects. I wrote a TTY maze game in Rust that was like pushing blocks from pushing controls, which was pretty fun. Actually, how to use like the VT100 terminal codes to draw to a terminal nicely was something I did for my, I picked up from some of the school last summer. So I had fun playing around with that class.
You mentioned about unsafe Rust
Yeah.
tokenomics.
Oh yeah, so in addition, there's a Rust book which talks about sort of details about Rust. I've skipped a number of cool things about Rust, like enums, and that should be on there. So you should check out the Rust book and learn more about it. And then the sort of dark arts of how to use unsafe are the Rustonomicon, which is another companion book, which is being worked on. It requires a deeper level of understanding to be able to write safe, unsafe code. So I wouldn't start there, but it's cool that it exists. You can sort of step past compiling and be like, I know what I'm doing, I'm not just really interested here. Or you can't understand here.
What IDE do you use and how is that getting supported?
I use Vim, and Vim works fine. And terminal window. There is a bunch of work being done on the sort of Rust language server. So like the Balan language server format was one introduced by Microsoft for their Visual Studio Code.
Oh, VS Code?
Yeah. And that's being picked up pretty much by the Rust community. It used to be like Racer, I think, but I think most community effort is going towards the Rust language server right now. And NeoVim is getting language server support, and just language server support popping up in a bunch of different places. Even apparently Summon quite likes the language server support, so it's maybe showing Linux for other things. So that's sort of the story for IDE. It's not like IntelliJ or something at this point. IntelliJ is pretty awesome, and it is not that mature yet, but they're working on it. I'm pretty sure they got GDP support and everything working fine, so you can debug it using those kind of tools. And if your editor supports shelling it to GDB or like the breakpoints and things, that will work fine. I haven't really played with that too much.
So if Rust doesn't have classes, yeah?
No, it
How
doesn't.
are you doing inheritance or anything object oriented?
So you really go for the sort of composition over inheritance ideas. It does have a few things to make it easier. There's auto deref. There's a trait for like, there's a transparent reference into something, which is used for a lot of the smart pointers. I think the people working on the Gecko stuff wanted some inheritance type of thing to map to DOM for their JavaScript. So there's been a few proposals thrown around. It's not something that's been like ruled out forever, but it has not been sort of settled or finalized yet.
So what is when I first read about the trait system, like traits have inheritance,
Yeah.
and what's missing that they want to implement classes as well? Like, is it data inheritance? Is that what it's supposed to be?
It's DOM. It's mapping from the DOM structures really nicely with like
Like you've got traits, you've got trait inheritance, you've got polymorphic references to trait objects.
I think that there's some issues over like when you have a trait object,
Yes.
it's not. It doesn't. I don't think carries a reference to like each of its trait inherited ones. It has the one larger V table for like this notation for that trait or something. I don't know the details of it.
Okay.
I haven't really been plumbing with us and like how they want to do the inheritance. One feature I entirely skipped over was which also helps with this, is you can implement sort of enums in Rust, which you can see in my tiles and flow all and exit for my base game. You can have nice match statements on them. But in addition to you can also have them as tagged unions. Do I have? Yeah, so for example, my state enum has either wandering, charging, or stun, and number of ticks has left to be stunned. And this will behave sort of like a union, except I can a tag union, which stores which state it's in, so I can match on that, and then sort of like my update function, I'll say like if I'm wandering, I'll pick a random direction. If I'm charging, I'll do some work. Or if I'm stunned and I have no reference to the counter, I can decrement the counter and then continue on with if it's returning your state. So these are very much like Haskell abstract, or ADTs, algebraic data types and things, which make it really nice for representing alternative states without just being sort of like a set of flies that like some data which you then have to sort of interpret as a union. It's much nicer to do it this way. I think C++ is trying to add type unions as a thing, but it's kind of fascinating.
I wouldn't expect it to be great, but given their constraints, but yeah.
But this is a big feature. Why I didn't talk about it in my talk. It's a really cool thing that Rust does nicely.
Yeah.
And makes these sort of state machines, which like this game is a state machine for like reach, control, behaves differently, much nicer to write. Yeah, that's a feature I regret not having slides for. I should I'll revise the talk again and change everything. All right. Other questions? Yeah?
If you wanted to get started with Rust, what's the tutorial you advise getting started?
The question is, if you want to get started with Rust, what would you start with? And I'm pretty sure the Rust book, also rustlang.org, or rust-lang.org is like the homepage for the language and has references to all documentation and book and everything, as well as how to actually install it. And I think it's book.rustlang.org. It's online. I think they're planning on publishing it in No Stars Press soon already.
Or is it changing every month? By the time
They're mostly done editing. A bunch of the early chapters are done because there's shipping offices and presses. I think the last few chapters were being revised a bit as they sort of did a second pass through. But I don't know, that information is like a few months old. It could also just be like actual presses are and wasn't following too closely. Also, the IRC channel is quite friendly. It's on the Mozilla network, not the free network, but their IRC channel is a good place to ask questions and things. They had a discuss, I think? Discuss. The forum software thing. Discord, that's Discord. Discord is a chat, voice chat.
Discuss is a common.
Discuss is a common. And then, is there another one?
Is a form.
Got it? Sure. I'm confused by all those very similar D names. Yeah. They have one of those for people to talk about things too. There's also a very nice subreddit, which is r/rust. They're pretty friendly.
So, from a big picture perspective, I don't know how to phrase this politely.
What's the point?
The Rust versus C, the Rust versus C++ question in terms of, is it actually saner? And also, when you're programming, how long does it take before you're not fighting Rust to get basic things done?
It takes, like, fighting Rust compiler is a thing that happens especially early on, and there's still a few areas they want to fix up, like, we'll still fight the Rust compiler for, like, indexing hash table and grabbing the key out and then doing things to it, putting it back in is not as nice as it could be, and they're doing some exciting intermediate representation changes to allow the compiler to be smarter about lifetimes, so you don't have to fight the compiler there, because what you're doing is safe.
But how long does it take you to get up to speed?
I didn't go all as a full-time thing on Rust, but I sort of followed it casually for a few months, and then I spent a few weekends writing some things. But it isn't bad. It requires thinking about how you're laying your data a little more explicitly than you would otherwise. Especially if you're sort of used to just allocate everything on the heap. I mean, if you do that, though, you can in Rust just be like, give me a new copy of a string, don't give me a string reference, just give me a new string, give me a new whatever, just sort of be free with your memory and be like, just give me more dynamically allocated things. You can stop thinking about will this reference live long enough quite a bit and just go ahead and write your stuff and then go back later and try and optimize it down and be like, look, I can make a zero copy parser and don't have to copy anything and sort of always read and then write that stuff.
Yeah,
But if you don't mind making some intermediate string copies, then it's fine. You're not going to fight the compiler over anything. It's more that the compiler to sort of taunts you by being like, look, you could probably make this even faster, and then you go and try and make it happen. But if you're okay with just making copies that you would otherwise and not trying to reduce as many copies as you could, you can fight the compiler a lot less like that.
Okay.
It also has a few things like reference counted cells, or reference counted pointers and things, where you can go ahead and not think as much about the lifetimes as it lives as long as it does when I want to use it. I just sort of check that nobody else is using it before I do at runtime instead of compile time. So you can push off.
Yeah, like C++ has shared pointer.
Yeah, it's
and
basically
you can
that.
adapt a programming style where you just put everything into shared objects and then use shared pointers everywhere, and then you just don't think about it.
Yeah, you can do that in Rust too.
Yeah.
I mean, it's probably not even the worst idea. And slowly, when you have things that you think you see how to use it, go ahead and optimize out and
Yeah, get it first get it working and then optimize it, right?
Yeah, I mean, a few places where thinking a little bit about your data structures ahead of time will save you a lot of trouble if you wanted to refactor it.
Yeah.
So Rust prompts you to think about those, but you can put it off for a while. I don't know. It took me a few months of weekends on and off to be okay with writing things, and then it was write a bunch of code and it gets better.
But you were also coming from a C background.
a C and Haskell background. I knew both.
Right. So, but then arguably that means that you had like the perfect background to be a candidate for Rust
Yes.
Writer. If you came from like a Python or a Java background where you don't think about this stuff, it's going to be more of that, is it not?
Yeah, I spent a lot of time looking at different languages and things, so like it wasn't a big shock. I mean, the lifetime thing is new and kind of unique to Rust, but like it was in the academic literature. Rust didn't try and do too many like groundbreaking theoretical things as much as like take the stuff that's in the literature and implement it.
Sure. So, in your opinion, then, does it have shelf life outside of particular scenarios? Like, I understand Mozilla's really interested in it from a security standpoint because they want to make sure that the browser part of the sandbox is everything, right? But like,
so also we were writing their servo. There's a talk you should see. I don't know what it is, but we're going to talk about how their architecture is servo in their parallelization and going sort of down to find out the layout from like horizontal and vertical and back up. And instead of sort of like waiting for everything to finish going down and waiting for and then shifting back up, you know, like as soon as there's turn around and start going back up for computing span sizes and things. And they wouldn't have dared it just with that in C++ because they wouldn't know it was safe. Whereas with Rust, they were much more confident about that. So that let them try and get even more parallel approaches.
Yeah. Like, one of the things that seems interesting to me is this, the safety guarantee extends to concurrency.
Yes, it does.
It basically guarantees that you can't have data races or have, corruption due to multiple threads accessing the same variables. It forces you to use idioms that are safe. And my past experiences with concurrency in C and C++ is that using P threads and that sort of interface, it's horrific.
Yeah, I don't have enough experience with the concurrent things to give a super informative thing here.
Yeah, I suspect that might be a killer app for us, but I don't have the. I haven't actually tried concurrent
I mean,
programming.
that's what Mozilla wanted, was it safe enough that they could use it for concurrent connections.
Yeah.
To try and get that page loaded faster. For page job.
Yeah.
So yes, concurrency is a big thing. I completely not talked about it because I'm not qualified. So I haven't really needed it for what I was working on. But it exists and so on.
But it's still questionable if you get the same performance like in C++. If you watch some videos about, if they go at low level of CPU, cache pipeline, and weird things happen there, If you are on a maximum performance, like in a heavy computational multi-threading application, I think C++ is still the king.
I mean, so Rust uses LLM backend, and it is pretty equivalent to like C in performance when it comes down to these kind of typing things. So it definitely isn't like being slow as usually. It aims to be as fast as C for all these things. And sometimes because of stricter aliasing rules, it can actually get faster code gen. Because you know that nobody else is there for this array, you can avoid some registry reloading. Or two arrays are different because you have two home pointers or some things.
Yeah.
So there's some instances where the stricter aliasing rules work out in your favor. But really it aims for parity to C because it just goes to LLVM and that all has a machine code. So you can also write in ASM Rust if you want. I did a little bit of that when I gave event stuff because I didn't have to. There's something that you need to provide for those targets.
But you can basically write C code in Rust.
Yes, you can.
All of the operators and operations are there. You can write the same code.
Yes.
So
You
shouldn't
can
be
do a
limited
one-for-one
performance.
sort of Rust code to C code, or C code to Rust code translation it will look kind of ugly in Rust, but you can use like unsafe pointers and just have exactly sort of the same semantics as C if you want, and then you can gradually sort of shrink that if you want. That unsafe area and come up with that. But if you want, you can write C in Rust syntax. That's possible.
Yeah.
What I was saying is, if indeed Rust assures, this thread safety at high performance, yeah, I mean, if you go and check, atomic operation in C++, yeah, it's a big issue. So some people are saying you cannot reach atomicity 100% in high performance multi-threading application, yeah, because low-level implementation of a multi-step CPU cache pipeline. And if you go and research, you'll see what the issues are there. So yeah, it's still questionable if Rust can solve these problems. Yeah.
Okay. I don't know if it's got a super fancy code generating. When I have used atomics in Rust, you specifying like which O-ring, CST or whatever, when you're accessing them. I don't know. That's a question to say. Cool.
Anybody else have any questions? Topic before done?